Every day, there are 17 people die waiting for an organ transplant, and every 10 minutes, another person is added to the transplant waiting list. To save more lives, scientists all around the world are researching on artificial organs. 3D printing may have something to offer. Hi, I'm Lisa, and this is Threshold in China, a segment that gives you a taste of the future before it actually happens. Let's talk about new tech of organ 3D printing. The current organ printing technique faces several challenges. In most 3D bioprinting methods, the bio-ink needs to be pushed out smoothly and then quickly made stable so that the printed structure stays in place. The 3D printing of organs, human cells are usually the key ingredient of the bio-ink. If the cells are not held in place, they could be damaged and the structure would not be correct. The next challenge is making the exact replicas of the complex organs, complete with intricate internal structures such as the blood vessel. If a heart you are printing do not have blood vessel to support the muscle cells, nourishing them with nutrients from the blood, the cell won't survive and the organ will be useless. To print an organ filled with vitality, scientists from Beijing's Tsinghua University decided to infuse it with spirit. Spirit stands for sequential printing in a reversible ink template. The sequential printing here refers to the two stages of 3D printing involved. The first stage is to print the complex geometrical structure of an organ that contains chambers. The structure could then be used as a template providing support for the second stage, when the blood vessel network is printed. The secret to spirit is the special bio-ink it uses. One of the key ingredients in the bio-ink is microgel, which has an amazing ability to heal itself. This healing works kind of like how jelly reforms itself after being cut. The microgel used in spirit contains the same substance as gelatin, which allows it to heal at any point after it's printed. Another important ingredient in the bio-ink is the stem cells wrapped up in the microgel. When the microgel is printed, it forms an organ structure containing chambers. The structure provides a framework or scaffold for the stem cells it carries to attach on and grow into muscle cells of the organ. How to print the fine lacework of blood vessels with narrow channels? The slim, hollow space inside the blood vessels are too complicated to print using conventional technique. After all, you can't directly print the void. So instead, the scientists decide to print a network of blood vessels with ink that can be washed away later, creating the voids. The ink used can dissolve in water or other solvents, so it can be easily removed without damaging the organ. They print this ink directly into the gel-like organ structure freshly made from the first stage. And they have to do it quickly before the microgel form a solid structure. Thanks to the microgel bio-ink's self-healing ability, they are able to do this without the worry of damaging the structure because the open wound on the printed material can quickly heal. After the printing is completed, and wait until the microgel structure is set, leaving behind a small organ with a complex vascular network. After 14 days, the heart muscle cell will have grown and covered the whole organ, which will begin to beat like a real heart. So how good is it according to the threshold standards? Well, let's move on to the threshold rating system: readiness, novelty, and potential impact or rippleness. As we mentioned before, the readiness category refers to the maturity of a technology, from lab demonstration, that is a 1, to mass production, that is a 5. The novelty score refers to how new the innovation is. 1 means small differentiation to existing technology, and 5 means that the innovation fulfills a new function. Finally, the ripple scale, as we call it, is our opinion of a technology's potential for life-changing impact and how widely it can be applied elsewhere. So how does spirit technique stack up? The organ printed by researchers from Tsinghua University is actually not quite an organ, but an organoid. Although they have the essential characteristics of an organ, such as muscle construction in this case, organoids are much smaller and are usually grown in laboratory. In other words, it's just a proof of concept for now. The researchers didn't say when they might be able to scale up to print a real organ. There are still hurdles to overcome before the spirit technique could have widespread applications. As the researchers pointed out, structures printed with the soft microgel-based bioink may not be strong enough to hold their shape or withstand external forces. It is clear from this that the technology is still at a very early stage of development, which is why it is a tool in readiness. The biggest innovation of this spirit technique is that it enables the printing of complex vascular system through which fluids such as blood can flow. This is revolutionary in organ printing, and it is a 4 on the novelty scale. As for the potential influence, as mentioned earlier, there is a long waiting list for organ transplant. Any meaningful steps towards meeting this demand could have a huge impact on millions of lives. So it is a solid 4 on the Ripple scale. With 4 on 2 categories, you can see the spirit is high, only that it takes time to cultivate. There's probably one more person on the waiting list since we started. Clearly, the ability to print organs cheaply and on a large scale has huge economic and social implications. There is also the added benefit of eliminating the use of immunosuppressants during post-transplant care, since an organ printed from the patient's own cell samples has little chance of being rejected, unlike being donated an organ from another human being. As to the ethical issue, consider that illegal organ trafficking may be completely eliminated if organ can be printed cheaply and may even perform better. I'm also wondering about other possibilities with this innovation. If the brain is just another organ, can that be printed someday too? And what about muscles, ligaments, or skin? How far before organ printing becomes so advanced that we start to redefine what it means to build artificial intelligence? A 3D printer replicating a flesh and blood human being. So how far do you think 3D bioprinting can go? As usual, we look forward to hearing from you.